Okay, so about 4 days ago, Anton Petrov uploaded a video talking about this new galaxy that was discovered. It's the new largest galaxy that we know of, and this is just some more stuff about it that's really interesting. So before, there were people that were believing that the biggest galaxy was IC1101, and there's actually, believe it or not, this is actually interesting because a lot of people didn't know this existed. There's actually a bunch of other radio galaxies that had not been talked about, but they were, like, they published papers about it, so some of the stuff was just buried in, like, studies and all that. But even it went over my head for a while, and, like, I've made a video talking about, there was, like, this galaxy, it was, like, J14 or 45-25, and then it had a bunch of other numbers after it, and it was a radio galaxy that was like 15.3 million light years in diameter. And basically why radio galaxies get so big is because in the universe there's like two different types of matter. There's matter itself, and then there's like radiation. But it's kind of weird because in quantum physics it states that, you know, matter and radiation eventually do become the same thing, but they're still two different things in a way. So what's really weird is, you know, you have galaxies like this that, because they're so big, it's because of how much mass they gather and how much radiation it gives off. So it's able to produce such a huge galaxy. So who knows, like, what's in it? But before, you know, but there was this galaxy before this one galaxy that we just discovered, which is now 16.3 million light years, and the one that I knew about was like previously like 15 million light years. I think it was rounded up or rounded down, I gotta remember. But it's interesting to think that, you know, there were so many other galaxies out there that we haven't discovered them yet, because, you know, obviously there's so much to even think about, and at the same time though, there were so many things that have been published, but they just don't meet headlines because most people don't know this stuff exists. So you don't have like editors and chiefs and science trying to figure this out. It's interesting, like, how much stuff gets discovered faster than they can process and put it out. So basically, so if you have a galaxy that's 16.3 million light years, and you times that by 5.88 trillion miles, because that's how big light year is, assuming that that is true, because it's possible the speed of light might actually be even faster than that. But, you know, but needless to say, you have galaxies that might actually be even bigger than what we think they are, because even though they're so far away, there's an elliptical illusion that they might be moving so fast, you know, because like Albert Einstein once said with like theory of relativity, that everything moves so fast and everything in space is made of energy. You basically get this concept and this paradox where every object in space might actually be even bigger than what we think it is, because we can't really accurately measure it because it's so far away and it's moving. And I know that sounds, some people would probably say, yeah, that's true. But it's crazy to think that you could have a galaxy that's like 16.3 million light years, and yet you times the circumference, if you were to take the circumference, you times it by 3.14, and you would have an even bigger estimation of like how big these like some of these objects really are in space. And so if that's true, then it's like, you know, it makes me wonder how many other planets are out there, galaxies, civilizations, and it really makes you think, you know, this is all found in the third dimension. So even in the observable universe, objects in space are much larger than we can comprehend, and therefore it really shows you how much we really don't know, because we're so used to seeing like what's in front of us. Meanwhile, the universe could be expanding in such a direction, in all directions, in more than one way that we can even comprehend, and there's so much happening, or so much could have happened in the past, depending on where you want to go back in time. But it just goes to show you that, like, an object in space that's like that huge is basically, you can't even begin to even compare some of the stuff, because like even our galaxy, for example, isn't even close to how big that is, let alone at all. You know, even our solar system is still like, you'd have to, I forget how many astronomical units it would take to equal 1 light year, but it just gives you, you know, even if you took like just the circumference of our galaxy, or circumference of our solar system, and there's like trillions of comets that are near the perimeter, and that's just one area. So it kind of makes you wonder how much we don't really see out there when you start really trying to wrap your head around all these metrics that we're not so used to seeing every single day.